Time value of money. Over a period of time, the value of money changes. Suppose if we bought a product at rupees 100 today, after few years or 5 years, the same product A cannot be at rupees 100, but we have to pay some extra money over it to buy the same product after few years, which gives us an idea that the value of money had decreased. So with the passage of time, the value of money decreases. Now we come to an definition: principal amount. Which is denoted by P, and this amount is the initial value of money which we either borrow or deposit. So initial value of money is the principal amount, and next term is interest, denoted by I or sometimes R. It is the extra money paid over a period of time to the principal amount P. Then we have another definition, which is accumulated amount. Which is denoted by A, and this is the final value of investment. That is, the accumulated amount is the principal amount plus the interest over this principal amount, which is the final value of money. Now we'll first learn how to calculate the interest. Suppose I deposit a rupees of 10,000 at the rate of 15% per annum yearly basis. Over a period of 2 years, then the interest after 1 year will be 15 divided by 100 into 10,000, which is equal to rupees 1500. And if we see interest for 2 years total, will be rupees 1500 into 2, because every year you get the same interest in simple interest. That is why I am multiplying it by 2. It is 3000. So the interesting fact here for the simple interest is that every year the principal amount P remains same. Therefore, the accumulated amount after 2 years, let us write this by subscript 2, will be the principal amount which was initially plus the interest after 2 years. So it will be, for this example, accumulated amount after 2 years will be rupees 10,000 plus rupees 3,000, which will be the rupees 13,000. So to calculate simple interest, we will use the following formula. Simple interest will be equivalent to principal into rate into time divided by 100, or you can say principal into I into T, where I is the interest and all, and here I have just written I by R by 100 because I is in percentage, I percent, and we know percentage can be converted into hundreds. That is why I am using these two. So it is not a big issue. And if we see principal amount P, then over this principal amount we get an extra amount which we interest, and accumulated account is therefore principal amount plus interest, which is equal to P plus I. Since I is the same, which is now, let us suppose principal amount is P and simple interest is denoted by simply I. Then the accumulated amount will be P plus I. Since P remains the principal amount, but I is here, which I have written by simple interest SI, is P into I into T, which is time. So this is equal to P into 1 plus IT. This formula we have to remember, and we have to remember this formula. So these two are important formulas which we should remember. And in fact, we have discovered this formula from this. Now we will come towards the compound interest. Let us come back to the same example. Suppose principal amount for the 10,000 and interest was at rate of 15% per annum, and suppose we will calculate it year after year. If you remember, the simple interest I calculated for a 1 year is principal into rate into time divided by 100, which is equal to principal is 10,000 into 15 into 1. So simple interest after 1 year will divide by 100, and it was rupees 1500. And the accumulated amount after a year will be principal amount plus I1, interest after first year, and it will be 11,500. Now interest for the second year. Now we will calculate the interest for the second year. If you remember, in this simple interest we have always year after year we get to the principal amount 11,500, 10,000 in the previous, but here the principal amount will change for the second year. For the second year, the principal amount will be rupees 11,500. So this is the major difference between the simple interest and compound interest. Now interest for the second year will be principal amount into rate into time divided by 100. But you should remember, I am calculating for 1 year, for which the principal amount is 11,500. Sorry, here is 100 at a rate of 15 into 1 divided by 100. So this will come to this will cancel, so it will be something 115 into 1115, which will be 1725. You may have seen charged the interest rate is never simple. Usually all charges are based on compound interest because the principal amount changes year after year. Or I can say time to time. Principal amount changes time to time. Let us look at the second example. Suppose we have to calculate the compound interest over rupees 20,000 for a period of 2 years with a percentage of 18% per annum. Simply, the interest for the 1 year after 1 year will be rupees 20,000 into 18 divided by 100. So 1, so we will write it as 1. Or I cannot write 1, so there is no issue. So it will come over rupees 1600, because these two will go, these two will go. It will be 3600. Therefore, amount at the end of year will be the principal amount plus interest after a year. So it will be 20,000 plus 3600, and it will be this thing. Now if we check, therefore amount for the second year, therefore principal amount P2 for second year will be this 23600, that is A2. Now when we calculate the interest for the second year, so we will see it is principal amount into or into T divided by 100. But we should note here we are calculating interest year by year, so that is why I am using T again 1. So P2 is for this year this into 18 into 1 divided by 100, and now it is easy to calculate, which is rupees 4248. Therefore total amount after second year will be rupees 20,000 plus the interest for the 1 year, which was initially so amount after first year will be like that. A2, it will be principal amount for the second year plus interest after the second year. and which is 23600 plus 4248, which will be rupees 2400. Therefore, when we calculate the interest for the third year, it will be this same amount will be the principal amount for the third year. So for the third year the principal amount will be this. Now when we try to find the interest for the third year, so it will be simply this P3 into R divided by 100, because we are taking t as 1 as t equal to 1 as we are calculating interest year after year. And total interest for the 3 years will be interest for first year plus interest for second year plus interest for third year. In compound interest, the principal amount was changing, so the interest per year was changing. Now in compound interest, suppose again principal amount is P and I is R by 100, which is the rate of interest, and time is n years. Then accumulated amount, that is total amount after n years, will be principal amount into 1 plus I power n. That is simply equal to P into 1 plus R divided by 100 power n. Therefore, compound interest will be equal to this accumulated amount minus principal amount. And remember, in simple interest, we use the formula P into R into T divided by 100, which is interest after T years. And here in simple interest, accumulated amount is P plus simple interest. We usually denote simple interest by I, that is P plus P into R into T divided by 100. Taking common P, we write this as 1 plus RT divided by 100. But in compound interest, the accumulated amount is P into 1 plus R divided by 100 power n, and here this is this. When in terms of I, the accumulated amount here is P into 1 plus I power n, and here it is P plus I. Remember these two things and we will get the idea.